Okay, today I'm going to talk about particle acceleration by the solar wind. I've got the piece of paper on the desktop there, but that's just while I'm doing a bit of narrating. I'm going to put up the Sapphire project right now, an excerpt from the Thunderbolts conference in 2013, the tipping point, and we're going to see a gentleman talk about how he doesn't understand how particles are accelerated, and then I'll show how.
So, Sapphire result expectation. Now, what this is pointing to is the things that we're going to be going after. We're going to be looking for ion acceleration. Now, from my perspective, I do physics, I do engineering, I do consulting, and that's what I get paid for. And I'm going to tell you right now, I accept that it takes a force to cause something to accelerate, and we all know that. But what force is that? I can see if there's a coronal mass ejection, it's possible that maybe the particles can maintain their velocity. That's for me a little difficult to handle. I would expect them to decelerate, but I sure would never expect them to accelerate as they leave the sun. It's just not. They don't start to speed up. They shouldn't do that, but they do. Okay.
Okay, so this is what the solar wind looks like. This is straight off of just looking for solar wind, and as you can see, it's got two lines coming off it that spiral around. Now, as I've said, there is a double helix running through the sun and through every single planet and every atom, because that's the energy that is everywhere. So I'm going to bring up the paper now. Okay, so here we go. Particle acceleration. So we've got our two lines that we saw was the solar wind. Now, I have said, and pretty much proved it on my last video, that energy moves matter. Matter cannot move. It doesn't. Atoms are turned by energy, the planets are turned by energy. Matter will never move unless you add energy. So as you can see on the picture there, I've got a straight line through the middle, and you can see a 10-mile distance arc in the center. This is moving slowly. On the outside we have, these are not real distances, but just for argument's sake, on the outside there we have 1 million miles. This is moving fast. Now, because the solar wind is a spiral, which we see coming out of the sun as a double helix, the particles get caught in this rotating solar wind, but because it's electrical, the outside is moving as fast as the inside. It is keeping up with it. It doesn't get left behind. So what happens is what you just saw on screen. The particle is accelerated because it has to cover the same distance of 1 million miles in the same amount of time that it covers 10 miles. So as I just showed, which I'll show again, that coin and a ruler, once you rotate it, and because energy moves matter and the wind is rotating and moving the matter along, as it goes out to the edge, it speeds up. Thank you very much. My name is Lee, and I'm a Christian.